introduce a new topic today, and we're going to look into iteration. We're looking at it different ways over the next few days. Some of it starts to dig into some very higher level mathematics. We'll kind of try to tame it a little bit so it's something you can understand. And so iteration is our topic, and the definition of iteration is just the repetition of a process. And for us, that process is going to be some sort of a math equation. So one example would be like a bouncing ball. When a ball bounces, it rebounds at a percent of what the original bounce was. And then it keeps rebounding back at that certain percentage. So an example would be that it rebounds 0.78 or a 78% of its previous height each time it bounces. If the ball is dropped from an initial height of 5 feet, when will the bounce height be under 10% of its original height? Well, I'd like to think that at the math level that you're in, that you could find out that 10% of 5 feet is just 0.5 feet. So that's what we're going to do. We're going to sit here and iterate this process until we get to 0.5 feet. So h sub 0 here, that means initial height. So we know that the initial height is 5. And then all I'm going to do is I'm going to take that times 0.78. And I've done some of the math here a little bit to get us going. So then the next height would be at 3.9 feet. And then if I take that times 0.78, I get 3.042. And then I'm going to just keep this going until I hit that 0.5. So then if I take it times a 0.78 again, I'm at this. Didn't really give myself much space. I feel like I'm a ways out from this. So I'm going to go ahead and write some heights here. Let's see if we get it there by the 7th height. Let's see. So then I'm going to take that times 0.78. Now I'm at 1.85, still not there. Take it again, 1.44. You're going to find in your calculator, this is really easy to do because once you set the tone of it and you take like the 5 times 0.78, and then if you just do times 0.78, it'll say answer times 0.78, and then you pretty much just hit enter, 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 and it will keep taking your answer times 0.78. And I'm still going here. All right, keep hitting enter. Guess I'm not going to make it. So now I'm up to the 8th bounce, maybe even to the 9th bounce. Yep. Here I am at 0.68. Actually, that would have been a 6.9. Then oh man, I'm so close. Still not there. Looks like it's going to happen on the 10th bounce. All right, so some of this is taking advantage of some of the features in your calculator. And I finally did it on the 10th bounce. I was underneath the 0.5. Now that's a very iterative, very repetitive process. So you do want to let your calculator, make your life easy. Like I said, get that set where it says answer times 0.78, and then you're just going to hit enter, 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 enter. Let's try this with just an algebraic equation. So it says find the first 3 iterates of this function. So the initial value is 2. So what you're going to do here is you're just going to plug 2 into the function. Now, I don't know how much work you need to show for this. I would tend to do a lot of this in my head until the numbers started getting bigger. But I'm just plugging 2 in right here. So that's going to be 8 minus 5. So the first iterate is 3. Now we do it again. Now take 3 and plug it in. So that's going to be 12 minus 5. Now take 7 and plug it in. That's 28 minus 5. And that's all they want, are the first 3 iterates. Okay? Now, let's look at this next one. It says find the first 10 iterates. Okay, you can tell this is going to feel like it gets tedious. They've given us a new function and a new initial value. So I'm not going to really show this all the time. I'm just going to list it out like it's a sequence, like when we did that. So if I plug my -1 in here, My first iterate would be a -1 squared, that's a positive 1, minus 1. That's 0. All right, the second iterate, I'm going to plug 0 in, and then I'm going to end up 0 minus 1. That's -1. Then I'm going to plug -1 in. That's going to be 1 minus 1. That's 0. Plug 0 in. What do you think's happening here? I mean, I'm not going to get something different just because I got a new iterate. It's 0 and -1, and it's just toggling back and forth, back and forth. So I'm sitting here just doing this until I do it 10 times. I don't know. Am I at 10 yet? There it is. That was it. Okay, so there's a couple situations that this iteration process is very common. One of them is an amortization, which is a repayment of a loan. So when you get like a car loan and they make you pay a certain amount every month, the amortization is the breakdown of what you're paying, how much is still left on the loan. Okay, and a second situation is working with population, whether it's growth or decay. I'm going to do one of each of those types of examples. So let's start with just a simple interest loan for a used car. So the loan is $3,000 and the interest rate is 9%. Okay, that's a pretty high interest rate for a car loan, but whatever. Maybe you have bad credit. Monthly payments are going to be $137.05. So derive an equation for the balance after in payments. So what you kind of have to figure out is, all right, once I've made a payment, what's my new balance? All right, then I make another payment. What's my new balance? Make another payment. What's my new balance? Okay. Now for our equation, we have some different notation here. So we're trying to derive the equation that's going to figure this out for us. B sub n is going to be our balance after in payments. So if this is a B sub 5, then that's after 5 payments. Okay, B sub O, remember, always going to be the initial. So I already know that the initial in this example is $3,000. The interest that you have to pay on this is always going to be whatever the balance of your loan is at that point times the monthly interest rate. So a couple things to talk about there. So early on, when you still owe $3,000 or $2,800, you're having to pay your interest on that full value. So you end up paying a lot more interest early on. As you start paying that off, paying it off, and now you only owe maybe like $800. Now when you're taking that interest rate times $800, you don't have as much interest that you're paying. And it is worth noting here that when you do make your monthly payment, they immediately pay off the interest first. They get their money first, then whatever's left over from your payment, that's what goes towards the principal to start breaking down how much you owe. Okay, now that's how it works. Let's also talk about this monthly interest rate. 0.09 is always an APR, annual percentage rate, so we'd always have to divide that by how often you're making payments. We're going to keep it simple and just do it monthly. So this monthly interest rate is really 0.09 divided by 12, which is going to end up being 0.0075. So that's going to be our monthly interest rate that we use. All right, so let's get started. We're going to jump in and we're going to write this equation. So this is a recursive situation. This repetition, this iteration, it's all just a recursive rule. So to find the nth payment, I'm going to always have to look at the n minus 1 payment. What's the term before it? Okay, so I am going to look at what was the balance previously. So I'm kind of thinking like if I were to make the first payment, this is sort of the first payment, then I would look at the term before it, which is the 0, because it started off at 3,000. So I owe the 3,000 plus I owe any interest in that first month on the $3,000. So that means I'm going to have to take the 0.0075 times, now I say 3,000, but that's just the first month. So I'm going to take it times the previous month, which I'm going to write like this. All right, so now I have the original amount of the loan plus the interest I've earned this month, I'm sorry, let me take that back. The interest that has accumulated on that loan. The bank is really earning that interest there. So the original amount of the loan, what I've ended up accumulating that I owe in interest, but also what happens in that first month is I make a payment. So that's going to bring it down. So I'm going to subtract the $137.05 that I'm going to pay. Now, if I'm really going to do this, I probably want to simplify this equation up as best I can, because what I'm noticing is that I kind of have some like terms. This is sort of like it has a coefficient of 1 on there. So it's 1 times the previous term plus 0.075 times the previous term, which really just means take 1.0075 times the previous term. So I'm going to simplify that piece up. And then I'm going to subtract the 137.05. So that's going to be the formula that I need. It asks me to find the first 5 iterates. Well, the initial isn't really an iterate. That's just the $3,000. That's where it started. So the first iterate is when I put a 1 in for this n. So when I put a 1 in right here for the n, then that means this is b sub 0, so that's going to be 3,000. So here's what I'm going to type in my calculator. I'm going to go 1 point, and I'm sorry, if you don't have your calculator, you should probably grab it and do this with me. I'm talking through what you type. Might be good for you to do that so you know what I'm talking about. If that means pause the video and go grab your calculator, then do so. Okay, so one more time. I'm going to do 1.0075. I'm going to take it times the 3,000, and then I'm going to subtract 137.05. Okay, now I forgot to say this. I am doing this all in one shot. Don't press enter. Don't do it in steps. I'm kind of what we call seeding that formula. You're starting it right there. So then I press enter. And my first iterate, so after 1 month, I owe 2885.45. So even though I paid 137, I didn't really end up, this is more like $115 lower than I started because I had to pay some interest and the bank took their interest money first. Okay, now what I'm going to do is I'm going to just hit times, because what I'm doing is I'm seeding this right here as my answer. Well, now this is the answer. And I'm going to take that times that 1.0075. I'm going to continue on all in one shot here. Subtract 137.05. So what I have on my screen is it says answer times 1.0075 minus 137.05. I press enter. I get 2770.04. And now because I seeded it with that term answer, it's not using an actual number, it's always using the previous answer. So if I just press enter, it just does it again with that previous answer, which now is this value. All right, so now I've got a 2653.77. Press enter, do it again, 2536.62, hit enter again. This was the thing I told you couldn't do during our sequence and series chapter. You can't just sit there and press enter, enter, enter. All right, today we're pressing enter, enter, enter. All right, there are the first 5 iterates. And Excel works really good for this too. You can create this formula and then just drag it down and you have this like printed out version of the iterations. And so you can kind of see how many months before this thing's paid off. Now the second place that we use this iteration a lot is with a population model, and it kind of represents changes that happen in a population. This time I'm going to give you the formula. This is actually called the Verhulst population model, and it uses this recursive notation, but it's a little bit different. This time, to look for the next term, remember the n plus 1 term is the next term, then I'm going to take the n term. Well, think about that. Isn't this just the term right before the n plus 1? So it's just a different way of writing it. We learned this in that chapter on sequences. That's ultimately doing the same thing as this right here. It's just a different way to write it. Okay, so to find the next term, I'm going to take a term, add whatever the rate is, which is the growth rate, times the population, and that n is telling the number of time periods that have passed. Okay, and then it's a 1 minus. So you're just using this p sub n several times. P sub n is the percent, I said it was population, I'm sorry. It's the percent of maximum sustainable population. So it's sort of like how close are we to like maxing out to what the environment can sustain. So let's say that the current population is 1,000. The maximum sustainable population is 1,500. Our growth rate is 15%. All right, so those are just normal numbers, but we sort of have to fix them for our population model that we have up here. So when it talks about the percent of maximum sustainable population, let's figure out where we stand on that right now. We're currently at 1,000. We can sustain 1,500. What percent of that maximum sustainable are we at? Well, you're simply going to do this, and I would do this in your notes so you have this for later. You're going to take 1,000 and you're going to divide it by your 1,500. Now that's a pretty easy number. That's just 10/15. That reduces to 2/3. So it looks like we are currently at about 66.6 repeating percent. Okay, now what we want to do this time, I'm going to kind of change it up on how we do this, is I'm going to have you seed that number, because that number is going to change. As our population grows, we're going to get closer and closer to this 1,500, making this percent continue to increase. So in this formula here, this P sub n, this number is going to change after every iteration, because we're going to keep getting bigger and bigger and bigger. So what I'd like you to do right now in your calculator is seed this. So what that means is go ahead, type it in your calculator, do 2 divided by 3, get the decimal, whatever you need to do there, and just press enter. Okay, you have seeded that. So now the formula that we have right here, every time I see this, I'm actually going to type answer. And by that's like that second answer button on your calculator. Because what it's going to do then is if I can always refer back to the previous one, I don't have to change that manually every time. Here's what our formula is going to look like when we type it in. To find the next term, I'm going to take my answer plus my rate. That's my growth rate right here, but we're going to write it as a 0.15. So 0.15 times my answer times 1 minus my answer. Okay, now you have to have seeded the 2/3 first. So you got to do the 2/3 equals where it's sitting there. So now what I'm going to type is second answer plus 0.15 second answer, open parentheses, 1 minus second answer, close it, press enter. And what I got was the next percent. So the next percent, what I got when I hit enter was 0.7. So I'm at 70% after 1 unit of time. Just press enter now. Oh, now I'm at 0.7315. Okay, I'm going to maybe just round to 2 decimal places on this because it's going to get longer and longer. Press enter. Okay, now I'm at 0.76. I'm getting closer and closer. Now I'm at 0.79. And I guess my question is how long before we hit the max? So I'm going to keep going here. Sometimes, I mean, this is good for whatever population this is. They got some years in them. 0.86. But it's not really growing as rapidly. Do you see that? I mean, 88. Okay. And now I'm at a 0.89, so man, I'm going for a while now. 0.91. Now, there are fancy ways that you can seed this in your calculator if you wanted to research it. It's kind of cool. Because you can have it keep track while you're doing your enter, enter, enter. You can also have it keep track of how many times you pressed enter, 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 enter. Because what if my question wasn't like, write out all the iterations? It just said, after how many years or months, whatever your time frame is, will you hit the maximum sustainable? Well, that's when I hit 100%. So you can count it, but invariably you lose count after a while. I'm going to go ahead and try to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm at 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, I'm going to say after 28, I finally got to a 0.995, which would round to a 100%, I guess. So I'm going to say that after 28 months, 28 years, whatever, they've maxed out. Now, there weren't really any questions on this. It was just, here's the example. I'm just showing you all the different things that you can do so that you can answer the questions on your homework then. All right, that's all I've got. You've got a worksheet for homework. Go give it a shot. Bye.